Hello, everybody. This is Dr. Zhang. We're talking about general physical science online. This is our lab 5, trying to give you a short instruction. So this lab is about isotopes. So what is isotope? First of all, we have to start from defining elements. An element is specified by something called atomic number, which is the number of protons. As the number of protons change, you have different element. Secondly, we have another number called mass number. So this is the number of protons plus neutrons. And when you have same number of protons but different number of neutrons, you will have different isotopes. Okay, so isotope is defined for same element, but so that they have same number of protons, but you may have different neutrons. In nature, it depends on the element. You have 1 or 2 or 3 or 4 different kind of isotopes for each element. Finally, this concept called atomic mass. It is actually you're calculating because of you have a couple of different isotopes. Each isotope has a different percentage in nature. So when you add them together, take an average, then you may end up with a number of its decimal places. So that's where this atomic mass come from. So the first tab, first part of lab going to here, that's what it looks like. So for example, for hydrogen, right? So what is showing you here is for this element, it basically, you can click on any one of the elements. As you can see here, most of the elements here just has only one isotope. For example, for hydrogen, the isotope most in nature is mostly it just with one proton with no neutron. Okay, and for other maybe different like lithium, right? There's basically two different kind of isotopes. One is the lithium 7, and then the other one is okay, not this is not stable. So you take one off. Okay, this is the other one. The other one is like lithium 6. Okay, so this number, okay, these two numbers here, the one number on top. Okay, first of all, one number at the bottom here refer to the atomic number, the number of protons. It defines basically represented by this red circle, red spheres here. This determines what the element is. And then the number on top is the atomic number, is the number of proton plus neutron. Okay, so in this case, you have 3 neutrons for 3 protons. That's lithium 6. Okay, so that's one isotope. Okay, you can add another neutron. It's still stable. Okay, say stable. And then this is lithium 7 is the dominating isotope. Okay. And because they're different percentage occupied in nature, so they have different atomic mass. Okay, so this is okay. Okay, I think that's enough for the first part of it. Some of them, like see, this most of them are very dominating by one isotope. Okay, you can very safely say that most of these are just one isotope. Okay, and then you just do answer these questions. Like what part of it? This is basically what just discussed. Okay, the same thing you can talk about here. So this question asks you the definition of atomic mass unit called AMU. That's the new unit. Okay, that's the used to measure essentially to measure representing this number this here. So uh to get this, okay, for example, use this to find the approximate mass of one proton in AMU and one neutron mass. Okay, so you can simply go to here. Okay, so when you have only one proton right here, what is showing here is the AMU. So that's the proton AMU. Okay, a proton in this unit in AMU weight like 1.00783. Now you can also bring a neutron to it. Then this AMU would be one proton plus one neutron. You cannot get directly one neutron, but since you already have AMU one proton. With this number, subtract that number, you can get AMU of one neutron. Okay. Okay, the second part is missing isotopes. Okay, in this case, we go to the second tab here, mixture. Okay, so if you clear everything, okay, there are different couple questions asked. Okay, ber beryllium and fluorine, for example, they only have one stable isotope. Okay, so in each case, so if you click on this, okay, that's the first one, and there's only one kind of isotope, so there's only one pool of it. Okay, you bring one of them here, it tells you the AMU of that isotope. Okay, similarly, if you talk about fluorine, there's only one kind. So you bring one of them there, you have this number showing up. Okay, and then you can answer similarly. Two mass, I mean average mass of 2 and 3 using that picture here, and so for lithium is a little difficult, complicated because lithium, right, have two isotopes. There are two different pool of atoms you can choose here. What is atomic mass of lithium 6? Okay, so if you bring one lithium 6, you can see clearly the atomic mass in terms of AMU. What about atomic mass of lithium 7? Again, you can see this if you bring one of them. Okay. Now you want to average 3 lithium 6 and 2 lithium 7, you can simply bring 3 of them here, 2 of them here. So then you can take average. There's a formula for you. I mean, there's this number showing you. Well, you can actually take the average yourself, right? But basically just adding the 3 AMU of 3 lithium 6 AMUs plus 2 lithium 7 AMUs, and then divide by 5, right? So this it says describe method to calculate average atomic mass of the sample in question number 8. This is actually, I think this is basically we're calculating both. This is for question number 7 and 8, right? They're the same thing. Okay. Without using the simulation, basically you're just doing a appropriate average, which add all these number of atoms with different mass together, divide by number of atoms, right? Okay. Finally, test your method by create 3 sample mixture of your own. Okay, you can choose whatever you want, and then you can use this what you plan to do, put it here, but you can also double check with this table. Okay, with this simulation. Okay, I think that's oh, there's a one two couple problems in the end. Okay, so it asks you to calculate average atomic mass of titanium. So you have different, there's 5 of them with different occurrence. There's like 8%, 7%, et cetera, et cetera. So, yeah, just use your formula developed before try this calculation. It's a little complicated, but I think you can do it. Okay. If you have a question, send me an email. Okay, this is a little more. This is like a foreign, right? I don't think you. Okay, you can use this part to kind of help you to do this. This one. Okay, I think we don't have titanium here, but it's all up to just the first 18. But you can use the simulation to help you do number 2. Okay. Okay, I think that's it. Try to keep it short. So thank you for watching. See you next lab.